y'all. Today we're going to take a look at the last method for solving a quadratic equation, and that is the quadratic formula. So up to this point, we know how to graph it, we know how to factor it, we know how to take the square root, we know how to complete the square, and today we'll learn about the quadratic formula. You may have probably seen this in Math 1, but that may have been a long time ago, so we are going to get you straight today using the quadratic formula. So the solution of a quadratic equation in general form, ax squared plus bx plus c equals 0, is given by the quadratic formula, and this is the quadratic formula. So please write this down in your notes, highlight it, star it, something like that. And also you want to make a note that when you use the quadratic formula, your problem should equal 0. So when you are using the quadratic formula, make sure your problem is equal to 0. If your problem is not equal to 0, you may need to subtract 5 from both sides or add 2x to both sides. You may need to manipulate it a little bit, but make sure that your problem is equal to 0 when you're doing the quadratic formula. So we're going to go through and we're going to do 4 examples using the quadratic formula, and then we're going to talk about what the discriminant of the quadratic formula is. There's lots of songs and videos and things out there for you to remember the quadratic formula, but it is negative b plus or minus the square root of b squared minus 4ac all over 2a. But if you want to learn one of those catchy songs that are out there, there's nothing wrong with that. So let's get started with the first one. So we're going to solve 2x squared minus 6x plus 1 equals 0 using the quadratic formula. Make sure it's in the correct order, and it goes x squared, x, and then your number. So we're going to start by identifying the a, b, and c. So a is 2, b is negative 6, and c is 1. So label your A, your B, and your C. So label A, B, and C. And make sure it's in order. You can just read off your numbers. X squared, X, and then your number. From here, we're going to take these numbers and we're going to put it in the quadratic formula. This is the quadratic formula. So there's a negative already here. I'm going to keep that. Plug in B plus or minus. It says to do b squared up here in my formula. B is negative 6. So I'm going to put that in parentheses. Minus 4. Next, it says to do a times c. A is 2. C is 1. And this is all over 2. And a is the number 2. This is the most important step of the whole entire process. Making sure we take A and plug it in for A. Make sure we take B and substitute it in for B. Make sure we take C and plug it in for C. Because if you accidentally mix up some numbers, you're going to get the wrong answer. And you would have done all that work for no reason. Now from here, we can go through and simplify. 2 negatives make a positive. So that's going to be 6 plus. Then I'm going to go through and I can put this in Desmos in my calculator. I can do negative 6 squared minus 4 times 2 times 1. I can put all this in Desmos. And this number here is actually called the discriminant. So you can actually enter that in the calculator just like you see there. You should get 28. From here, 2 times 2 is 4. Okay, I can go through and we need to break down 28. So we need to simplify our radical. So I'm going to do a factor tree for 28 off to the side. I'm going to do a factor tree. 28 is 7 and 4, 2 and 2. So off to the side, I'm doing a factor tree for 28 because I need to break that number down. So I can rewrite 28 as 2 square roots of 7. So now my problem is 6 plus or minus 2 square roots of 7 all over 4. So what I did, I got the square root of 28. A couple of weeks ago, we learned about simplifying radicals. So I did my factor tree. Pairs go on the outside. Everything else goes on the inside. So the square root of 28 is 2 square roots of 7. The last thing I could do is simplify one more step. 6, 2, and 4 are all divisible by 2. So 6, 2, and 4 are all divisible by 2, so I can break that down. So my final answer is 3 plus or minus the square root of 7, all divided by 2. And this is our final answer. 3 plus or minus the square root of 7, all divided by 2. And we will say that we have 2 real solutions. So 2 real solutions. So recap, we make sure it's in standard form. It should go x squared, x, and then your number. You label your a, b, and c, and you substitute those into the quadratic formula that is up here above. So substitute those into the quadratic formula. Take your time and make sure you break everything all the way down. Now, this is the exact answer, 3 plus or minus the square root of 7 divided by 2. You could get a decimal approximation just by typing this whole thing into decimals. However, you're still going to have to know the exact answer, and the decimal answer can just be used as a way to check your work. So just be conscious of that. Okay, B, we're going to go through and do the same thing. Let's label our A, our B, and our C. So as long as it's in standard form and set equal to 0, you can read off A, B, and C. Now we're going to take this and substitute it into the quadratic formula. So it says to do negative B plus or minus the square root of B squared minus 4 times A times C, and I'll be out of your way in just a minute. It's a long formula to write down, all over 2A. All right, so again, my formula is up here. It says to do negative B plus or minus the square root of B squared minus 4 times A times C, all over 2 times A. This is the most important part of the whole process. And again, I'm going to circle what the discriminant is, and we'll talk about that after we finish our practice problems. This number underneath the square root is called the discriminant. It's going to give us important information about the problem. So the number underneath the square root is called the discriminant. So 2 negatives are going to make a positive. In Desmos or some sort of calculator, I type in negative 2 squared minus 4 times 3 times 4. You should get negative 44 back. Then you do 2 times 3, and that is 6. From here, I have a negative inside of the square root, so I can take out I. So 2 plus or minus I square root 44. All over 6. So I took out the imaginary part of the problem. So this is an I for the imaginary part. Now I need to do a factor tree for 44. So I need to break 44 down. So I'm going to come over here to the side, and I'm going to do a factor tree for 44. 44 gives me 11 and 4, 2 and 2. So 44 pairs go on the outside. Everything else goes on the inside. So I can write this as 2 plus or minus 2i square roots of 11, all divided by 6. So from this step to this step, I kept the I on the outside of the square root, and we replaced the square root of 44 that has been replaced with 2 square roots of 11 because we went through and we did our factor tree over here. Last thing, again, see if I can simplify. 2, 2, and 6 are all divisible by the number 2, so I can divide everything by 2. So our final answer is 1 plus or minus 1i square roots of 11 divided by 3. This is our final answer because we divided everything by the number 2. 2 divided by 2, 2 divided by 2, 6 divided by 2. This one that's right here isn't necessary. I just wrote that there, so when you go back and study, you'll see that we divided everything by 2. And this one problem, we have 2 imaginary solutions. So we have 2 imaginary solutions. How do I know that? Because I worked it out. So one of my answers is 1 plus I square roots of 11 over 3. And my other imaginary solution is 1 minus I square roots of 11 over 3. Okay, a couple more that we'll go into, and then we'll talk about what the discriminant is. Make sure it's in standard form. Label your A, label your B, label your C. The most important part of the problem is substituting these numbers into the quadratic formula. So we're going to substitute that in. It says to do negative b plus or minus the square root of b squared minus 4 times a times c, and that is all over 2a. So I took b, plugged it in where that went, b squared. Make sure you're using parentheses when you're plugging in your a, your b, and your c, and that should be the first step. This is the most important step of the whole process, making sure we substitute our numbers into the correct spot. Now, in Desmos, I can substitute this part into the problem. That is called your discriminant. So the number underneath the square root is called your discriminant. So the negative 2 here, I can't do anything with. We'll just leave it as negative 2, plus or minus. When I type all this in, I get negative 4 when I type that in. And 2 times 1 is 2. From here, I can take out the I part of the problem. So I have an I that's in here, so I can take that out. So I have negative 2 plus or minus I square roots of 4 all over 2. Okay. The square root of 4 is a perfect square number, so that's going to give me 2. So now I have negative 2 plus or minus 2I divided by 2. And as we can see, everything is divisible by 2. It's just a coincidence that everything is divisible by 2 with these first 3 problems that we've done. They could all be divisible by 3, or they could all be divisible by 5, or we possibly can't even break it down at all. So it just depends on the numbers. If we can break it down, we would break it down. But if we can't, then we would leave it just like it was. But for this problem, I can divide everything by the number 2. Divide everything by 2, and we'll get negative 1 plus or minus I as our final answer. So negative 1 plus or minus I. And this tells me I have 2 imaginary solutions. So 2 imaginary solutions. So one of my solutions is negative 1 plus I. My other solution is negative 1 minus I. So we have 2 imaginary solutions. And problem D. We'll go through, label our A, B, and C. A is negative 4, B is 4, and C is negative 1. So you can read it off as long as it's in order. Make sure it's set equal to 0. You can read off your A, your B, and your C. Now I'm going to take these numbers and substitute it into the quadratic formula. So negative 4 plus or minus 4 squared minus 4 times negative 4 times negative 1. And this is all over 2 times negative 4. So I took the A, B, and C, and I carefully made sure I substitute A in for A, B in for B, C in for C. Now we will begin the process of trying to simplify this. I can't do anything with the negative 4 on the outside, so I just bring it down, plus or minus. In Desmos, I can type in 4 squared minus 4 times negative 4 times negative 1. So the reason that we're doing this is because we want to really literally figure out what that number underneath the square root is, because it's going to tell us the number and the type of problem, type of solutions that we have. So that when I typed all that in, that gave me 0. 2 times negative 4 is negative 8. Now, the square root of 0 is just 0. So I do not need this at all. It does nothing. So we're left with negative 4 over negative 8. And negative 4 over negative 8 is 1/2. So for this particular problem, I have one real solution. So one real solution. So if I zoom out here, so we did the quadratic formula, and the part underneath the quadratic formula, which I've circled in green, so the b squared minus 4ac, That number is going to tell us what type of solutions we have and how many solutions we have. So notice for one problem, I had 2 real solutions. Another problem, I only had 1 real solution. And then we went through and did a couple of them that we had 2 imaginary solutions. So let's write out how do we know what type and how many solutions that we have after we've gone through and done the quadratic formula. So the discriminant is b squared minus 4ac. So this is the discriminant, not the whole formula, just this section right here. This tells us the number and type of solutions that we have. If the number is greater than 0, we have 2 real solutions. And that would be like problem A above. So like problem A above. If your number is equal to 0, that means you have 1 real solution. And an example of that would be like problem D above. So like problem D above. And the last case that we could have, if this number is less than 0, you have 2 imaginary solutions. So you have 0 real solutions, 2 imaginary solutions. So if your discriminant is something less than 0, meaning a negative number, then it does not cross the x-axis. There are 0 real solutions. There are 2 imaginary solutions. And we had 2 examples like that above. That would have been like problems B and C above. Now, let's draw in a graph to correspond to what we have here. So we're working with parabolas and quadratics and things of that nature. So I'm just drawing in an XY coordinate plane, and we're going to go through and sketch graphically what the discriminant is telling us. So again, I just sketched some coordinate planes here, and we're going to go through and draw some parabolas in and make some connections to what the discriminant tells us. So if my discriminant is greater than 0, so any positive number, I have 2 real solutions and it'll cross the x-axis twice. Okay. So I drew in a parabola, a U shape, and it's going to cross the x-axis in 2 spots. Now, it could be flipped the other way. That's fine. The only important part here is that it crosses the x-axis twice, meaning we have 2 real solutions. The next one, if your discriminant is equal to 0, you could have where it only touches once. So you could have something like this. Okay. So this one only touches once. So you could have something like that. And if you have your discriminant where it's less than 0, it is not going to cross the x-axis at all. So it's going to be just chilling up somewhere. So it is not going to cross the x-axis at all. So let me zoom in so we can see that a little better. So if your discriminant is greater than 0, it's going to touch the x-axis twice in 2 spots. If your discriminant is equal to 0, it's only going to touch once. And if your discriminant is less than 0, notice this parabola here is not touching the x-axis at all. It will not touch. It means there will only be imaginary solutions. So up at the top of our paper, when we went through and we did the discriminant, it told us automatically how many solutions we were going to have. Okay. This number is bigger than 0. 28 is bigger than 0. So that means we were going to have 2 real solutions. Negative 44 and negative 4 are less than 0. So that's why we had 2 imaginary solutions. And the last case that we have, what if it equals 0? If it equals 0, it tells us that we have 1 solution. So the discriminant tells us the type and how many solutions that we have.